We got emails and calls from viewers this morning asking us about a foul smell.
It was a burnt type of rubbery. You can tell it was like some type of chemical.
Putridy. It was sour. It just had this horrific. It was horrible.
Township police were inundated with phone calls from residents complaining about the foul, putrid odor overnight that literally woke people up.
The Allegheny County Health Department is investigating to determine a source. The vice president of manufacturing for Neville Chemical Company, Dan Kokoski, says the plant had an incident with one of the packaging vessels and a chemical was released that has a sweet hydrocarbon type odor. He also says the smell didn't match up to what some people reported, so they're working with the health department to figure out if the smell came from the plant.
On September 2, 2021, Neville Island Chemical Company released 24,800 pounds of volatile organic compounds into the air of the greater Pittsburgh area. This release was caused by a leaking heat polymerization valve that allowed a raw material to enter a resin kettle, then finally releasing a hydrocarbon mixture into the air. This leak continued for 5 hours, and for 5 hours Neville Island exceeded the county limit for hazardous air pollutant release by almost 2,000 times. This video will be demonstrating two different COMSOL multiphysics models that depict a similar scenario to the pollution event at the Neville Island Chemical Company in early September. The first model will display a standard barrel of heptane diffusing into the air over 5 hours. The physics of this model will be the transport of diluted species. For this model, the hydrocarbon heptane will be the solute diffusing into the solvent that is air. This model was created using the 2D axisymmetric model wizard. The geometry used to represent the heptane is a rectangle that is 35 inches tall and 23 inches in diameter, the size of a standard barrel. The airspace above the heptane is located immediately above the heptane block and is a rectangle of the same size. The initial conditions needed for this model are the concentrations of the heptane and air in each block before any diffusion. For heptane, the initial conditions are 6,825.67 moles per meter cubed, calculated from the density of heptane at normal conditions. The initial concentration of air is 44.46 moles per meter cubed, calculated from the ideal gas law at standard conditions. On the top right is a picture of the heptane block, and below that is the air block. The COMSOL model was animated in order to best display the results of diffusion over time. Because diffusion does not occur at steady state, this model is based on a time-dependent study. To be as close to the actual Neville Island event as possible, this model shows the evaporation of heptane over the course of 5 hours or 18,000 seconds. The animation video takes a data point every 20 seconds until the 18,000 seconds is reached. The resulting animation video is composed of 50 frames, with each frame showing for 0.1 seconds. Here are the results of the 3D animation. The animation clearly displays the diffusion of heptane into the air. The air becomes a lighter and lighter blue over the course of the video, demonstrating that the concentration of heptane in the air increases over time. Furthermore, the apparent surface of the heptane moves downward as some portion of the heptane diffuses upward. Here is the same animation in the 2D view. Now we are going to take a look at a new model with the same concept of heptane diffusing into air, but on a much larger scale. This new model will feature the heptane diffusing into an airspace 10 miles long, which is the distance from Neville Island to the University of Pittsburgh. Here, there is a cube of heptane with 2.6 meter sides, making the size of the cube 17.6 meters cubed. A container of this size will hold approximately 24,800 pounds of liquid heptane, equivalent to the mass of the hydrocarbon mixture that was released by Neville Island. The heptane will be diffusing into an airspace that is 1 mile high and 10 miles wide, with a very light imposed breeze of 2.5 meters per second in the x direction and 2.5 meters per second in the y direction. The top image shows a zoomed-out overview of 1 mile by 10 mile airspace. Below is a zoomed-in image of the model, showing the heptane container located at the bottom left corner of the airspace. Here are the results of the 2D animation. The heptane is seen diffusing into the air, initially as a smaller, more concentrated cloud. As the heptane continues to move in the wind, it diffuses further, becoming less concentrated and covering a larger area. The animation covers 10,000 seconds, or slightly less than 3 hours, which is about the time it takes for the heptane cloud to travel over the 10-mile distance. This time frame is logical and agrees with the news coverage of the incident. The Neville Island leak began around 3 a.m., and many reports of the smell were made about 3 hours later. Finally, let's take a look at the COMSOL model's application to mass transfer. First, the driving force for this diffusion is the concentration gradient between the heptane and the air. Initially, the concentration of heptane in the air is 0 moles per meter cubed. As time goes on, diffusion continues and the concentration of heptane in the air increases. Next, the method of mass transfer in this model is the binary diffusion of heptane in air. The equation used to calculate the concentration of heptane as a function of position and time is shown below. This equation includes the accumulation term, the diffusive term, the convective term, and the generation term. These transport phenomena concepts are a wonderful tool for modeling real-world events, just like what happened at Neville Island. Using mass transfer, we were successfully able to model the diffusion of a volatile organic compound into air over time.